Our next example, a disk starts at rest and experiences constant angular acceleration of 4 radians per second squared. When the disk has gone through a total angular displacement of 50 radians, what is its angular speed? All right, well, just like with our translational motion, a good starting place is listing out what we know. Can we clearly identify, what's been given, what we're trying to find? So let's just go through and pick out these key details. Starts at rest. All right, that tells us our initial angular velocity is 0 radians per second. We have a constant angular acceleration of 4 radians per second squared. Angular acceleration is alpha. All right. And then when the disk has gone through a total angular displacement of 50 radians. So here, the angular displacement is our delta theta is 50 radians. It's asking what is the angular speed at that point. So angular speed at this moment in time is omega. So after it's been accelerating, after it's traveled through 50 radians, how fast is it going now? And just like with our kinematics before, once we've identified what we know, that's going to help us narrow down which equation to use. So we're looking for omega. So one, we have to use an equation that has omega in it, so we can solve for that. And there is a variable that we have no information about, and that is time. So ideally, we can jump to an equation that doesn't have time and does have omega and all the things we know. And indeed, the third equation here fits the bill. Omega squared equals omega naught squared plus 2 alpha delta theta. And so we are looking for omega. We'll leave that variable in. The initial angular speed was 0 plus 2 alpha is 4 and delta theta is 50. So omega squared is 2 times 4 times 50, so 400. And then we need to take the square root of both sides. And the angular speed at that moment is 20 radians per second.